Okay, sorry for network disturbance. Am I audible? My voice is clear. Is presentation visible?
Yes, sir.
Yes, sir. So, as we were discussing about the device manager and what exactly the cross functional architecture. Now, when we say a cross functional architecture, it means what? A device manager, on the other hand, which is responsible for connecting your device, having a correlation with the different types of communication protocol, then it is responsible for managing the identity and access also. So, it is giving us a different functionality on the on one platform. That's why it is a cross functional architecture. So if we look at the identity and access manager, so there are some specific to the authorization or the authentication category or services which are related with these category, means the security services. So first one is the policy control. Let's finish with the identity and access manager first, and then we'll deep dive into different protocols of the IoT communication. So once we talk about IAM, in a short, identity and access manager or management, called it as IAM. So once we are having IAM equipped devices or any kind of a cloud platform or any of the offline platform, because IoT devices or the IoT device bed is not only being connected to a cloud, but we can have an internal server infrastructure where we can host our some what we can say services. Like I have given you example of a SCADA system which is acquired by MSEB, the Maharashtra Electricity Distribution Corporation, or any of the SCADA systems or any of the RTOS systems which are open source IoT operating systems. So these operating systems or these kind of a management systems are going to be deployed on a server architecture which is not a public, so which is a private server architecture, or we can say a private cloud in a better sense, because ultimately we are accessing that service from remotely or from a remote location. So there, once we are having these kind of architecture installed or architecture ready to go, then for a security we'll be implementing IAM. So there are different stacks of IAM. So this is not the security session, so I'll be not deep diving into a IAM, because if you can see the gravity of every single protocol or every single section in IoT reference architecture, it is having so much to tell. Like IAM is having so much to tell, device manager, even if we take a particular protocol like XMPP, MQTT, CoAP, or any other protocol, it will take lot of time. Us 2 or 3 days will not sufficient to discuss everything in that, because it is having a very much designated work which is happened, and the outcome is that what we are seeing it in on a broader scope. So on a broader scope, I'll be taking up IAM with the four main policies, or we can say services, not the policy, sorry, with the services. First one is a policy control. Now, what exactly a policy is? So policy means a set of rules. Of course, we all know this. So the policy is a set of rules, but this policy is specifically drafted for the devices, not for the user. So this thing we need to keep in mind that, so the whatever the policy we are designing, this policy is designing or implementing on the device level, not on the user level. User level policies are there, but it will be deployed on the application layer, or we can say that it will be deployed on the dashboard level, or when we are creating an application, that time that policies or user level policies are going to be applied. What kind of a user level policy would be that a particular user is having a limited privilege account, so what kind of a privilege over that system that user will have, or administrator will control what type of a services, and what type of a service will be controlled automatically by the system itself. Because again, administrator is a user, and there is a user and there is a human sitting behind the user screen. So it is very difficult for a human to control each and every step what this mechanical devices, electronical devices are taking place, or the software which is taking. So we will be having a control where we can control it. So the administrator, if we can see, will be having a control over the system, like 70 to 80% control over the system, and 30 to 20%, depending upon the scenario, that entire control or some crucial instrumental control is on the system side only, that will not be going to control by the user. But yes, we will be having a override option in that case. Now, the very good analogy or the scenario in this case would be if you are having a nuclear plant. So where you will be generating a nuclear energy or you're doing the stuff. So the entire plant is setted on a automation category, and one we can say that there is automation which is playing a vital role behind that. But there is always a failure or certain conditions of the failure. In that case, human can take over the automation. So there is always a manual switch where when we feel that computer, CPU, or whatever intelligent machine we are having is getting fail in a certain condition, we can manually switch it. Another example can be, it is not related with the IoT, but you can relate it as the policy control. Another example would be your autopilot in aircrafts. So nowadays, all the pilots are switching autopilot when the aircraft reaches to a particular altitude, and then CPU, onboard CPU, is finding out the trajectory, coordination. Sorry, not the coordination. Coordinates to the destination, and then that plane is moving, or that plane is heading towards that destination. Even once it is reaching to a waypoint where it needs to climb or it needs to descend. So depending upon the situations, that autopilot is adjusting the route and the pace of that plane. And once pilot feels that now the autopilot may cause trouble sometime, or when there is a big turbulence or air drift, or we can say a air pothole is there, then that time these pilots are switching off the autopilot, because they know that in this certain condition autopilot may fail and we can be in a very dangerous situation. So there is always a manual button when we are having these kind of a policy control. But here the policy control is for the device, which device, based on which factor needs to be entered in our environment. Like the biggest factor is a trust factor. So once the device is trusted and the device is signed as a trusted device or a valuable device or accepted device, then only the device is able to communicate on the channel. Now, how do we trust the device? So it is totally depend upon what type of architecture you are having. So in our demonstration, what we will be doing is we will be taking up our node MCU, connecting to a cloud, and we will be sending out our sensor data on the cloud. So there we are writing out the channel and the API key. So once we are giving an application programming interface, that is the API key, that there itself a policy control is making exception that whatever the information or the sensor is getting connected to me as a cloud service provider through this API is having a trusted application or having a trusted implementation, or that device I can trust, and then the communication happens. So there are different types of policy controls we can have. We can have access control policies, we can have device level policies, we can have device access policies, we can have network reachability policies, we can have network latency policies. So there are different types of policies what we can have, that we can configure or we can create. Not, it is not always that we can configure it, or else some, in some condition, if we are having some application which is not giving us a configuration pane of uh, IAM rules, then we can create the IAM rules for us, and we can get a better control over that device deployment. So this control is majorly onto a device deployment and device usability. Then we are having authentication with the two token assurance or issuance. So there is a two factor authentication or 2D authentication, way more than there is a three-way authentication as well. So there will be a different types of authentication tokens which will be generated by our system to validate that device, to validate the certain device and their certain information as well. So for example, if we can take the same example at the NFC, so once you're having your debit card placing onto a NFC enabled POS, then that POS needs to be creating a token. So once that token is uploaded on a authorization channel, so that there can be a authorization server. Once that server is reading that token, and if that token is satisfactory, then only that NFC transaction is moving ahead for the bank's approval. Otherwise, that transaction will be failed or returned there itself. Now, why we require these kind of a tokens? Now, when we are dealing with the most valuable information, in that case, we need to authorize that device to carry out that communication. So maybe in this case, there can be a cases like we have a POS device, because getting a POS device is not a rocket science. You can go on any online website who are selling POS devices, and you can get the POS device with you, and those devices are NFC enabled. Or you can go onto any electronical shop where the IoT or the hobby case kits are so getting sold. So there you can ask for the NFC read and writer, like the NFC read and writer I'm having. So there you can read that NFC card properly. So we need to authenticate on which POS or on which device that card is getting read, that is the validated device or that is the authorized device or not. So in that case, we can use the tokens. Now, this can be a transactional example. Now, if we move towards the healthcare, and if we can take this analogy further, so whatever the device I'm using for ICU, that device needs to be authenticated. So if you visit hospitals, then you might seen some nurses, or male nurse or female nurses, are wearing some shiny buttons on their uniform, or maybe it is like a bracelet. So that is what, that is the NFC or a RFID token. Once they are reaching to a certain machines where the extra authentication is required, there that machine is taking that authentication to identify the person who is going to operate on that machine. Not on the operation theater, the machine's operation, who is going to operate that machine, is that person is trained, or that person is a valid user for that machine. So basically, MRI, CT scan, or ultrasound machines, of the highly sensitive ultrasound machines, or the machines which are using radioactive waves to investigate, in that kind of application, there is an extra layer of security which is required, which can be happened through the token. Similarly, if we move around on the metro, if you are into a metro city, then you can see there is a token which is issued as a ticket. Now that ticket needs to be inserted into a particular barricade. So once you inserted it, once that ticket is validated, then only the barricade is getting open, and then you can take out that ticket. So once your destination is there and you wanted to go out from the station, then that ticket will be getting deposited in that barricade itself. So if you can see there, that is also an implementation of the token, not onto a two-way authentication, but similar kind of authentication where we can authorize that user, we can authorize that device to have a communication on it. So once we talk about the issuance, now what is the issuance? Whatever the final outcome we wanted to achieve. So whatever the final outcome, it can be your data transmission, it can be your validation, it can be your authorization. So whatever it is, that there we can have a better security. So if you are having a just a password and you are getting a two-way authenticated authentication by putting something on to that device, definitely they have implemented IAM with the auth 2, like auth version 2, that is the two-way authentication. Furthermore, we can have a 3D authentication where we will be authorizing the transaction through a third party validator. So what is the third party validator? So once we are tapping onto a NFC, now why I'm taking always a NFC's example, because it is very close to us and we are using NFC enabled debit card or credit card very frequently, or if you are not having any, then you might seen it every time when you visit a shopping cart or any shopping mall or something. So that's why I'm taking it. Instead of roaming around on the very bigger side, let's take it on the simpler one where we can understand it properly, because understanding a mechanism under a IAM is very important in order to implement it. So if you are trying to implement this in your further projects, then you are now having a clear idea how exactly IAM is working. So taking out the issuance or the 3D authentication. So once you are putting up your NFC card for reading on that POS device, a one call is given to the bank card issuer that whether this card is active or not. Instead of going directly to the bank server, that NFC reader will connect that POS, or that POS will be connected, not the NFC reader, that POS will be connected to the card issuer server. Maybe it is a Visa, RuPay, MasterCard, any. I have not seen a RuPay in NFC enabled card yet, but MasterCard and Visa I have seen. Even I'm having a Visa's PayWave card, that is a NFC enabled card. So what it will do is it will query to the NFC, it will query to the NFC manufacturer or the authorized company, card authorizing issuing company. So that issuing company will check it, or that server will take it into a consideration that this request is come and verified that the request in the database. Once that card is active, once it is getting a signal that yes, card is active, then it is querying to the bank. And once bank is queried, bank will check whether you are having a desired balance or not, and whatever the input you have given. So according to the new norms, it is now a 5,000 rupees a limit. Previously it was a 2,000, but it is not applicable to all the banks. The banks who are voluntary going to participate in this exemption, then they can. So I don't know about your bank, but my bank is providing me. So 5,000 rupees a limit now. So once I'm putting a 10,000 rupees for NFC, definitely bank will going to check what is the cap amount and what is the amount you have entered. And that amount is less than the cap amount or equal to cap amount, then only the transaction is approved, and you will be getting debited, or that merchant will get paid. Otherwise, the transaction will be declined. So in this case, a three-factor authentication is in place, as we are validating that particular card through a third party. Third party in this case, who will be the third party? The issuer, card issuer will be the third party, where we are authorizing whether you have issued this card or not. Why? There are the schemas available like the NFC, what the practical I'll be going to show you. So on that demonstration, you can see by just getting our NFC read and writer, we can actually clone our NFC card, and we can have that information embedded on a empty card. So in that case, some card IDs are getting changed. I'll be not disclosing it on an open channel, but definitely when we have a face-to-face kind of a workshop, then I'll be sharing you that, as I have already worked with the payment card industry for several years for authenticating all these communications. So there is a card identification number which is embedded on the chip, which cannot be cloned. And that way that card issuer can understand that this is a clone card and this is not the actual card, and can send a declined request. So there is what the third party which is authorizing your card, not the transaction. They are only authorizing the card. That is what the 3D authentication is. Or in a simpler manner, if you can say, the OTP what is coming onto your phone while you are putting your CVV number, everything on online payment, then you are getting a one type of a security. So that is also a 2D or a 3D kind of authentication. But still, on a device level, the NFC wala part, where it is authorizing through another different server, which is not in a transactional point or not in a transactional queue, because transaction can be authorized or declined by the bank only or the bank servers only, but it is taking a help of the third party or the issuer server, or the issuer company's server, because that is a third party in this transaction, and validating it. So that is what the 3D authentication is. Now, furthermore, if you wanted to have a IAM on the some kind of a service level, then you can configure LDAP, or you can have identity services called XSCML or PDP. So these services are running onto a port level, or we can say that onto a service level. So the first two, policy control and the two-factor authentication, working on the hardware level, on the device level. Once the device is authenticated and comes on the network online, then further authentication is going to be happened. If you wish, if the developer wish, then we can use LDAP, directory services, or identity services called XSEML or PDP. So where we can have an extra layer of the authentication. Now why we are going to use a LDAP? Because our device can be the main purpose of using LDAP is that if there are misplacing of the operating system level, though our transaction can be successful, means if I am transacting my online payment through Windows operating system, and suddenly I move to the Android and I wanted to pay it through my app, so that can be possibly done using LDAP. So that's why we are using LDAP. And on LDAP there are various security configurations what we can do. As again, this is not the security session, so I'll be not getting deep down into it, but if you wish, then I can send some reference material how exactly this IAM is working. So yeah, so that is what the IAM is. So IAM is totally focused on access management, user identity, and all types of authorization and validation kind of stuff. So there we can use IAM, or the identity and access management. Now coming back on the hardware part, device manager. So if you can see this illustration, so here we are having a device manager which is onto another side of the architecture, where we are having three agents listed in it. Now what exactly these agents are? Now consider these agents are the three different sensors what you have connected to your test bed, or what you have connected to your sensor bed, or a whatever the device bed you are having. So scenario would be here is you have connected all these devices on the bed, and then now that bed is online on a particular cloud service. So there is a device manager which is working for a betterment of a communication, or betterment on a communication protocol. So device driver is eventually getting connected with different types of a communication protocol, and definitely it is compatible with all types of a communication protocol. If some kind of a communication protocol which is new, and their signature or their what we can say compatibility is not with the current device manager, then that manager can acquire extra information about that, and we need to update our device manager in order to facilitate a new type of a prototype. So now why I've risen this query, that if there is no situation where this is a new protocol and there is no reference in the device manager, because that is happening as IoT is not that old field, and it is not very new field. So it is what on a moderate level field, where the lot of R&D is working on, a lot of R&D is going on. So because of that, lot of new protocols are emerging. Some are the successors of the older one, some are totally new, some are into consideration, and there are so many things, so many strings are there which is working together to make the IoT communication faster, safer, and reliable. So once we talk about faster, safer, reliable, then interportability again comes into the picture. We'll talk about the interportability once we finish with the protocols, right? Just give me a 1 minute, I'll be back. Just give me 1 minute. Okay, so let's start with our protocols now. Widely, these are the protocols which are used, or we can say that these are the common protocols which are used always in a IoT. Like first one is DDS, that is a data distribution service. Then AMQP, COAP, XMPP, LWM2M, then MQTT. Now let's see what these protocols are all about. Let's start with the very common one, that is MQTT. Is my voice audible? I'm audible.
Yes, sir.
Yes.
What exactly the MQTT is? MQTT is a messaging queuing telemetry transport. Now, this is very useful and low bandwidth consumption, or we can say it requires very less bandwidth to operate. So, it is designed for the battery powered devices. So, basically, when we are having any type of a deployment where we need to give we need to give external power supply, but using a batteries. So it can be a deployment of various environmental sensors which are onto a smart poles. Nowadays, smart pole is the concept which is booming onto a IoT field. So in a IoT, there is smart cities, or the smart city concept, or the smart city area. In that, smart pole is going on. So what exactly the smart pole is? Smart pole is having a just normal your light pole, having the different sensors and different displays on it. So it can have one environmental sensor, then it can have a security camera, it can have a SOS messenger, that is a security messenger, or we can say that emergency beacon messengers. Then it can have light, it can have your hotspot access point. So every time when we move around to a city, and those cities are under smart cities, they are offering free hotspots, wi-fi hotspots. So that is considered on that. Then the display for advertisement and everything, and that entire pole is powered by solar panel. So it is not getting a traditional electricity, it is taking from a solar panel. That's why it is called it as a smart pool, or the smart appliance pool. So in this case, what will happen is all these devices are connected with the battery, and depending upon the battery type, it is getting power on it. So all the power is getting through a battery. So of course, all these devices are a very low consumption devices, low power consumption devices. So once we are having a low consumption power devices, we need to have a protocol, or a communication protocol, which again requires a very less amount of a power in order to communicate on a network, or in order to establish on a network. Now if you observe, to prove this theory, I can give you a one interesting fact. So if you observe that there is no signal on your phone, and if you observe your battery on a phone, that is somewhat 60% right now, and you're not having any signals to it, and it is started searching for the signal. If you look at 1 hour back on the battery level, still you are not having a signals on it, and it is decreased to now 30%. Now why it is happening? Because of the communication protocol what LTE is using. If you are using a 4G band mobile, or if you are using a 3G band mobile, again on 3G also LTE is working. So depending upon the frequency ratio, depending upon the terrain where your mobile phone is, and depending upon the last tower location and the signal strength what you got on the phone, depending upon that your phone is static searching for a particular network. So once the phone is start searching, it emits the what we can say signals more stronger than it is having once with the associated, or one will be associated with the tower. So in that case, what is happening is it is requiring a much more power than what it usually requires. That's why it is always recommended to, if you are not having a signal, then put your phone onto a flight mode, so you can save your battery backup, battery power over there. So if you know terrain, or if you know the area where you think so, in this 5 kilometer or 2 kilometer or 1 kilometer, whatever it is, you will be not getting any reception. So after that you need to turn it on. So by that you can analyze, or by that you can observe the battery consumption what your phone is taking up, though everything else is turned off from your phone. Even your Bluetooth is turned off, everything is turned off, which is a high power consumption communication ports. All those are turned off, but still your this roaming profile is acquiring much more power. So in a smart pole kind of a condition, if that particular device or the set of device bed is equipped with the battery and it is taking up the battery power, then of course we'll be requiring some kind of a protocol which takes a very less power in terms of a consumption and can give you a proper throughput. So there is a good choice of taking up, that is MQTT. So MQTT is also working on a TCP/IP protocol, so you can have a specifically designed reliable communication networks to resolve your problem, to grow your chip level power supplies, or we can say you can have your objects which are onto a network which can be well connected on it. Even MQTT is again working on a TCP/IP, so it is having a reliable communication with QoSO, that is at most one, which is like which is most reliable and fast. Not sorry, this is not the most reliable, sorry, I'm sorry, that is least reliable but fastest publication what we can have. And but in this case you will be not having any kind of a confirmation which can be received. But if you are having S1, that time you can have what we can say feedback, like whatever you have sent, you can take a feedback whether that particular message is received at the end or not. And if you are having a QoS2 enabled on it, then it is most reliable, but it is most bandwidth consuming. So though MQTT is completely designed for a low powered equipments and low powered communication, but in that also some kind of energy is getting lost. So if you set your communication MQTT QoS2, then it will consume a more bandwidth, not more power, it consumes more bandwidth. And because of the bandwidth consumption is more, that device on which that MQTT is configured, and that device antenna is taking up the more power. So that is the case. So what will be the ideal situation? So if you don't bother about the recipient, or if you don't bother about the feedback, so it is just a broadcast session. Like in our case, if we wanted to take out the temperature and wanted to display it on our remote side, then there is we don't required a feedback kind of a mechanism where that temperature is displayed or not. So that time we can use the least reliable mode, and we can achieve a greater flexibility with the less consumption of the power. But in the case like we are using MQTT for tracking a GPS signal. You can use MQTT for tracking a GPS, so there is no kind of a thing. You can have a GPS installed on your machine, and you can take a MQTT input and take the GPS coordinate and show it on a remote site. That can be possible. But in that case, you required a feedback whether that particular coordinates is reached to the server or not. That time you need to get the S2, which is the most reliable but having a bandwidth consumption. So resulting, but there is a kind of a what we can say fault tolerance, or we need to set that it may happen like S2 can send repetitive data again and again. So that filtration we need to do, or that filtration needs to be done at the source level at least. If it is not possible on the recipient level, then it needs to be on the source level, and if it is not possible on the source level, it needs to be on a recipient level. So we cannot have a repetitive data. But moreover, if we can see the feeds or the needs of a MQTT, then it is a very minimum bandwidth requirement what the MQTT is having. Then it can perfectly work on a wireless network. It is having a very low rate of energy consumption. then it is having your reliability as per your demand. Like you can have a very good reliability with very good throughput, or you can have a okay kind of a throughput. That versatility you can have using the different in MQTT inside protocols or the inside methods of communication. Then it requires very limited processing and the memory resources to have equipped with it. Even the beauty of the MQTT is it is not only working with the TCP, it can work with the UDP well, when we are least bothered about the feedback. So that time it is definitely it is going to work on a UDP method. So once we are taking up a UDP communication stack, then definitely it is more fast than the TCP. Now, why it is fast? Because in TCP IP stack, if you can see, there is a segment called QoS, quality of service. So QoS, for the QoS, some bandwidth is reserved. But in UDP, we are not bothered about the recipient because we are not getting any kind of a feedback in that situation. So QoS is not going to reserved in a UDP, and ICMP is controlling the UDP directly and pushing up the whatever the message you have randomly, or we can say on the interval what we have set it. That's why it is most fastest way than the TCP. But still, if you want the reliability, we should always take up a protocol which is working on the our TCP stack. Again, moving towards a different protocol, that means there is again widely used protocol called constraint application protocol, that is a COAP protocol. Now it is having a designated addresses which is actually need a HTTP based IoT system. Now what will happen in this case is COAP is relies on the user datagram from in the UDP protocol. Of course it is reliant on the UDP protocol, and it is launched by the constraint application protocol by the IETF constraint restful environments. So if and it was launched in I think so in 2012 or 13, I think so in the 13, I guess it was launched. I'm not sure about it, but yes, I think it is possibly it is in 2013. I'm not holding it up. And what it will do is it is allowing for broadcast and multicast both the things. So it is having that kind of capability, and the UDP which is used is able to transmit data to a multiple host while we are in a communication speed and with the low bandwidth usage. So that is what we can say beauty of a COAP protocol, or we can say a constraint application protocol is. And again, this protocol is typically employed with the M2M communication or the M2N resource constraint resource environment. And again it is very much compatible with wireless networks which are typically what we can say deployed in M2M environment. Then another thing with the COAP, which is that it is shares the HTTP with the RESTful architecture. So giving its opportunity, like it is sharing the HTTP with RESTful architecture. It supports for both the request and response interaction model with the application endpoint. So if you are having a specific application hosted on a particular cloud environment, then there is a better reception when you are using COAP. And again, COAP adapts the basic get and post, even put and delete kind of methods, which actually avoids the interaction between the clients. We can actually there is ambiguity in that, and because of that it is not directly connecting to the client, and there is a IAM which we can implement properly and we can control it. And we can see that though it is using majorly a UDP protocol, but it is having a reception. So it is having a quality of service which use as a controlled messaging area, and we can have at least what we can say reception, and we can have a better communication over this channel. So that is what the COAP is. And as I forgot to tell that COAP is having a data transport layer security. So if we talk about the security point of view, because in MQTT it is much secure. Why? Because it is using TCP/IP, and once the TCP/IP stack is involved, automatically inherited security network architecture is getting involved in the communication. So similarly, COAP is majorly worked on the UDP, and there is no such kind of a reliability as there as the UDP is concerned, but still it is having extra feature called datagram transport layer security. Because of that, we can get what we can say a quality of service, and we can ensure about the some degree of security. I'm not preferring a word using just a security. I'll use a preferred word degree, some degree of security, because there is nothing 100% secure as such we can see. Now, moving towards the other communication channel, if you can see, that is the XMPP protocol. So, XMPP protocol is extensible messaging and presence protocol. So, if you can see, the XMMP is working with the XML, means it is going to be a protocol which is middleware based and the XML language based, and it is a protocol which is message oriented. And since it is having XML, it is widely applied on as a communication protocol. Why? Because cloud and the other devices is very well communicated in XMPP protocol, as it is commonly sharing XML file. So the XML file is very good containers for the instructions to be flowed. Even some license, if we wanted to get, or the authorization we wanted to get, that is also written into XML. So the XML coding is pretty straightforward in that case. Even it can be encrypted properly, so we can have a proper lightweight protocol, because XML again it is a very lightweight configuration language, so we can have a very lightweight protocol in terms of XMPP. So if we can see the other protocols as well, like data distribution service. So the architecture of the data distribution protocol is totally based on data centric publish subscriber layer. So that is the DCPS layer we used to say, and another is the optional one, that is a data local reconstruction layer. That is what the DLRL is. So DCPS layer, which is responsible for resource awareness, scalability, efficient data and the distribution and the subscribing. And in other hand, if you see DLRL, that is data local reconstruction construction layer, and if you can see that it offers interface of DCPS functionality. So it is totally interlinked between them. And if we go around with other protocol, then we can have advanced messaging queuing protocol. So as the name is suggesting, so it is having a messages which will be having queued. So by one it will have the communication end on that. So the AMQP specification, if you can see, it describes the feature as it is a message oriented, and it will have queuing, routing. But when we say a routing, it is not including point to point or publish to subscriber kind of a routing. It is general routing of the queuing, queued messages, not the queuing, sorry, queued messages. And it is much reliable and secure, as it is having inherited security policies as well. So what and the mainly these AMQP protocols are used in SCADA systems, because these are the very heavy systems or the industrial heavy machinery which are working on the SCADA, where we required a lot of protection and a lot of what we can say inside that data needs to be in insider kind of a network. For that we can use advanced messaging queuing protocol in that case, because those instructions are very straightforward. Then we'll have LWM2M, that is low weight machine to machine communication. As this name suggests, it is a low weight, means what? It is having a very lightweight effect when we are using it with the machine to machine. As once we are talking about machine to machine communication, it has to be having two factors in common. The first one is our reliability and security, and the another one is interoperability between communication. So once we talk about the interoperability, so what exactly interoperability means? The interoperability, it means that we can have our communication with each and every layer of the deployment very smoothly or very effectively. That is what the interoperability is. Again, the means of the interoperability is we can share our resources prominently. That is also the interoperability. So by other way, if you can see in nutshell, it is, these are what the interconnection capabilities and intercommunication capabilities. That is what the interportability is. And all the IoT stack is interportable or having a functionality of interportability. Right. So are we clear till this point? Any question, any doubt, or anything from participant side to add in this? Okay, so I guess there is nothing. Let's move to the another slide, that is IoT reference framework. So there are different reference frameworks out there, but the most reliable reference framework what I have observed is that is ISO 30141. So this reference framework, I'll be not taking very deep in this. I'll just take a glimpse of it, and later on I'll share the resources where the ISO 30141 is properly described, so you can have that reference. Because again, we'll short of the time and will not able to finish ISO in a given time frame. So ISO 3014 talks about the reusable designs. Now what exactly the reusable design means what? Whatever the device bed we have used, that needs to be extensible. Like if we wanted to discard that application and we wanted to use a different set of instruction on it, using some little changes or major changes on the device side, instead of disturbing the entire assembly, we can use the what we can say portable devices to connect with. So that is what the design needs to be a reusable. So if there is some changes in the runtime, that needs to be changed, means in the maintenance point of view, that has to be a reusable design. And if we can see that it is having a very best practices involved in terms of creating and deploying IoT architecture over the cloud or over the infrastructure, then we can have a secure standards which are stated in ISO 30141. Now what kind of a secure standard it is stated? It is stated like what kind of connections you need to perform, how the bandwidth needs to be managed, what if you are using a certain level of instrument, then how to tune them, then what kind of a protocol needs to be used in which kind of a communication. These are the guidelines, these are not the rules what ISO is saying. These are the very preferred guidelines. So if you wish, then you can follow these guidelines. Otherwise you can make your own way to deal with your communication. But if you follow with the ISO 30141 standard, then it is pretty much accepted in the industry, and your product what you have created cannot have any kind of a what we can say, it will not have any kind of a resistance from the market for acceptance. Then definitely it is having a commonly used vocabulary, means what? It is having the devices or the instruments, or configuration pins which are generally used every time. But again, that is your invention, so if you wanted to do something new, you can always do. So from this reference framework, if we can see from the ISO 30141, if you wanted to take out something, then you can take out like this is talks about reusable design, this talks about about the best practices which can be imported, talks about the secure standard, which talks about the commonly used platform. So these are the good takeouts from the ISO 30141, and based on that you can have your own invention, and then you can deploy your application whatever the way you want. Then there are different types of a standardization available in the market you can choose from. The like M2M, that is machine to machine service layer embedded in the hardware and the software, or we can have a Contiki, which is an open source operating system for low powered IoT microcontrollers like the Node MCU, or we can have a Zigbee, these kind of a low powered microcontrollers. Then we can have Light OS, which is based on the Unix operating system, which is a look like the Unix for a wireless sensor network. So RTOS or RTFL, the routing operating systems, which is generally out, which are the open source, which are generally out for not the RTOS, sorry, RTOS is top of that, but RTW, RTLW is the open source operating system, which where, or the framework we can say, where we can get our general purpose router and we can flash its original firmware with the RTWL, and we can get a lot of things to examine with that. So kind of light OSs. So you can use the light OS on the different IoT enabled wireless sensor network. So that we call it as a WSN, wireless sensor, Zigbee, LoRaWAN, GPON LAN, or TGGO, TGIO. Then we can have ESP8266, then LoRaWAN ESP. So there are a lot of things, or the room stake. So there are a lot of devices out there, or the technologies out there, which works together to form a wireless sensor nodes, or the sensing nodes. So there you can use LightOS. Then you can have RPMF as a proprietary standard for connecting IoT objects, or you can have Sigfox as, again, it is a proprietary one, but it is having a very low power technology in terms of machine to machine communication. So you can have all these standards, or you can get the open source standard to formalize your IoT infrastructure. So this slide is a very generic slide where we can talk about the IoT design considerations. Now, when we say IoT design consideration, now what exactly it means? It means that how exactly you are creating your bed, or your sensor bed, or a device bed, or your object. So these need to be, but not limited to these consideration. Whether your device is wireless capable, because as things are connected on a network, and if it is a wired connection, then we are having a very limited mobility. So if these are wirelessly connected, then controlling them is much easier than the controlling it onto a wired one. Then maintenance part is also easy. If the wired connection is having some breakouts or line break or something, then maintenance is very difficult in some situation, in some in areas, geographical areas as well, and it is somewhat costly. But on the wireless media, if something goes wrong with the network side, you can easily check out it at the client side, when the deployment side, or on the source side where the WSN node is deployed, and you can troubleshoot it much easier way. Then we can have a good functionality. So once we say about good functionality, now what we are having as a stay in that, good functionality means all the functionalities what we discuss in the business layer, what the requirement was, and how exactly these sensors should react on a certain situation, that entirely, and with the maintenance entirely needs to be considered in the functionality. Then we need to talk about the interportability. Of course, your each and every communication channel needs to have a interportability for a better use and for a better maintenance is. Then we can have a secure storage. If your device is emitting some kind of a valuable data, or kind of a data, when we say a data, it is always a valuable one. So once we are having this kind of a deployment where we are creating a database or where we are creating a data set kind of a stuff, then it needs to be stored securely on a cloud platform, or you need to have enough encryption mechanism. You need to have a API which are encrypting the connection ratio needs to be encrypted, connection type needs to be encrypted. So everything, the communication end which is creating a valuable data or fetching the valuable data, needs to be stored securely. Then immediate boot capacity. Now this is a very important part. Now what is the immediate boot capacity? Sometime you experience like once you turned on your Wi-Fi router, it is taking quite a long to get on a service. Like mine is taking way too long. If I turned it off, then almost it is taking 2 or 3 minutes to turn on, and after that 3-4 minutes more to back online. So it is not advisable that that kind of a delay can happen on a deployed application. So you need to choose a development board, or you need to you need to develop your boards as in the context like it can immediately boot your bootloader, and not that immediate, but it can have a very low tolerance and very low latency. Maybe in 10 or 15 seconds it needs to be back online. So that kind of a immediate boot capability it requires. Even I say that in uh, below 5 seconds. So in between 5 seconds it needs to be back on once the power is on or the power is restored to that device. So that is what the best way we can have a better performance over the IoT. That is what the immediate boot capacity. Then we should have a better device categorization. So like we are having a health monitoring system, or we are having any monitoring system where we are attaching more than two sensors, 3, 4, 5, 8, 12 or 13 sensors, 20 sensors we are attaching. So the placements and the categorization of these sensors needs to be well planned. Like if some sensors are working on to respiratory systems, then that they need to attach on a certain level. So the PCB what you are designing, that needs to be a very neat and clean, and needs to have all the connection appropriately connected. Not some sensors are on the way too far and some are very close to the power source. That need not to be happened. And the device data collection categorization is also important in that case. Now this another consideration, we need to see that how exactly your device is costing in a bandwidth. Like it needs to be a very low bandwidth consumption device. So once it is a very low bandwidth consumption device, of course you will be having a better performance in that case. Then we need to see that if your devices are somewhat using any kind of a biometric or any kind of a documentation or any kind of usage where we can apply cryptographical controls, means the encryption and decryption. If we are having any kind of a room to apply security in this manner, encryption and decryption manner, do apply that. So if someone tries to overclocks your device or tries to harden the device, there is a concept called in a penetration testing, in ethical hacking, there is a concept called penetration testing or system hardening. So there is a concept in IoT security called IoT system hardening. So in a system hardening, if someone tries to harden your system, then means what? Hardening your system means what? Doing the real time attack or doing the real time hacks on the device to check from which area or from which attack that device can be penetrated, and we can search for the remedial solution for it. So definitely if we are having any room to apply cryptographical solutions, then do apply them. And finally, सबसे important, power management. So your all things comes on two main things. One is bandwidth and another is power management. Once you sorted it out, low bandwidth, low power, then you win the game. And after that, the immediate concern comes for the security, cryptographical control, and secure storage needs to be there. So that way we can have a good deployed architecture or the good deployed application of the IoT devices or the IoT. Now I'll be taking this very quick. I'll be not getting into a very deep inside it. Um, So once we consider about the network and the cloud, and if you wanted to have a device architecture done on the cloud or having a network, then we can follow these four simple steps. First one is we need to have our devices which can network the things, means it can communicate on the network, wireless sensors or the actuators. Then the second stage would be sensor data aggregation systems to be done, so it can have a conversions, like if you're having analog sensor, then it can convert the analog data into a digital one, and vice versa. If you're having a digital sensor, then it can be converted into analog one, depending upon the requirement and depending upon what you wanted to perform, depending upon that. And the stage 3 will be edge IT, means what you need to have a devices, or you need to have a software part where you can examine, analyze or pre-process your information in order to feed it to another source. So on the fourth stage, you can have a data center or cloud deployed application where you can manage and archive your entire application process or the data what we have created. Similarly, the solution architecture, what we can see is talks about the pretty similar way. It have a sensor and actuator which is getting connected to a gateway. Then we can have a data acquisition systems where the data aggregation and the data measurement or aggregated data management will be happen. There can be a access control, there can be a policy control, so the IAM can be happening on that. So all these things can be possibly happen on the stage 2, and finally on the stage 3 we can have a pre-processing or the edge IT pre-processing on it, and data center can be deployed or the application can be deployed on the first stage, fourth stage on the data center. So that way we can have a better deployment. Now on the final stage, so this is the final slide what we are having. So this is what the architecture needs to look like. At the bottom we need to have a IoT device layer, then we can have a middleware which is talks about the gateway, and then finally we'll be having a cloud where the IoT platform is there, where our devices are operating, or we can control our device from the cloud, right? Sorry. Right. So this is all about the IoT protocol, infrastructure, and architectural point. So I guess this is for this session. We are open for question answers. After that, we'll take a short break, and then we'll resume with our demonstration using cloud platforms. Yes. There any questions? Any doubt? Okay then. So I think there are no questions. We'll take a tea break, and we can resume by 3 as we are taking a tea break early, or as per the organizers way, we will be resume at that time, because I am also needing a break and a tea as my voice is getting flat. Yeah. So see you after 15 minutes a break.